Let's take a look at a sample problem to see if we can see how the difference between an independent test is from a paired two-sample t-test. So in this example, a local health spa advertises to its clients that its clients lose a significant amount of weight during their 4-week weight reduction program. An investigation by the Better Business Bureau, or BBB, produces a set of data on people enrolled in the program. And we want to set up a hypothesis testing for the following. Now, the first question is, the answer to it is probably pretty obvious, but it's meant to show how an independent t-test would be set up. So in the first question, or question A, are men and women's weights different before the program? What we're asking is, we take all our men in the program, we take all our women in the program, and we ask, is their average weight different? Now, this is an independent t-test. We're comparing averages. Okay. Now, why do we need a significance test? Well, the reason is because there's a lot of degrees of variation in the men's and women's weights. So, for example, the zeros here represent men. So we've got a 203-pound man here, 157-pound man here, and so on and so forth. And then the ones represent the women, and you can see that there's variation in the women's weights as well. So we want to know, there is a difference. Is that difference significant? Or, do the corresponding weights overlap in their levels? Now, why is this an independent t-test? Well, you really don't have a man and a woman or the same individual in both groups. They're either a man or a woman, so they're independent from one another. So we're looking at them as a group, as a whole. In the second question, which is more interesting, did the people lose a significant amount of weight as claimed by the spa? Well, this is more typical of the type of test you would run with this data. It's a paired t-test. So why are we comparing averages? Well, in a way, we're really not comparing averages. We're comparing differences, and we're taking the average of those differences. Well, why do we need a significance test? In this problem, we want to know, is the difference in each of those individuals' weights, they're the average differences, equal to 0 or not equal to 0? And then finally, why is this a paired t-test? Well, we're not going to take the weight of one person minus the after weight of another person. There's a relationship between the weight before and the weight after. Another way that you can see this is if I were to scramble the data, take this weight here and bring it down here, and take this weight here and bring it up here, and there's no longer the relationship of before and after, then the data doesn't mean anything. I couldn't run a paired t-test. But if I were to scramble the data like that, I could still run an independent t-test. So let's start with the independent t-test. Step number 1, we want to define or formulate the null hypothesis. So we do this by representing the mean weight of men minus the mean weight of women equals 0. So we're assuming that there's no difference between the two. The alternative is that there is a difference. Notice that this is a bidirectional or two-directional test. So we're asking, is the mean weight different or is it not different? So we're comparing the mean weights here since we want to know or see if the typical man weighs more than the typical woman. The definition of groups 1 and 2 could have been switched. It really wouldn't have mattered. It would have just changed the sign of the t-value. I'm going to select the heavier group, or the men, to be group 1, so that the t observed value would be positive. Now, just like before, we have a normal distribution. This time it's the normal distribution of the differences in the means, where we would say anywhere in this range, there'd be natural variation, but we couldn't say that that variation is due to something other than sampling error. If we find that the differences fall outside of our confidence intervals, then we would say, yeah, there is a difference between the two groups. So we choose our significance level of 0.05. We select the statistic and we calculate its value. Now this is the output for this problem. Let's bring in Excel at this point, and so that you can see how we would run this problem in a class. So our question is, we want to know, is the mean weights before of the men different than the mean weights before of the women? This data set is available in your lab data sets. It's called GYM, GYM.XLS. And the first thing we need to do to this data is we need to sort by men and by women. So I'm going to go to our data tab and I'm going to sort. Yes, I want to expand the selection. And I'm going to sort this by gender. And it doesn't matter if it's smallest to largest or largest to smallest. So now I can create a new data set called men, new data set called women, and I can take all the before weights of men. Notice that I'm going to capture all the zeros here, copy that, and we've got the before weights of women. Now these two groups are independent. It wouldn't matter if I scrambled this side or scrambled this side. It wouldn't change. We're going to measure the difference in the means. Next step, we go to our data analysis Toolpak. Now we're going to be using a different tool than we have before. In this case, in section 6, we use the paired two-sample for means. In section 7, we're going to be using the paired two-sample as well as the independent or two-sample assuming equal variances or unequal variances. We'll talk more about the differences, but for this purpose of this problem, we'll use or assume equal variances. So we first input the first group, which will be men. Second, women. The hypothesized mean difference is 0. We'll leave that blank. We do have labels. And then I'm going to put this output here on the same page so that we can see the data and everything together. So we see that the average weights of the men and women are reported here. Men on average are 202 pounds. Women on average 135.5, so 136 pounds. Just like section 6, we've calculated a t-stat. Now the t-stat is calculated using what's called a pooled variance. But we use the same process. We compare that t-stat to the t-critical, or we can look at the p-value and ask, is it less than our alpha? Either way, the t-stat is greater than t-critical and the p-value is less than alpha. So in this case, we would reject the null hypothesis. Now, what does that mean? We can see we get the same output here. So we observe that our t-stat is greater than t-critical. Using the p-value, we know that our p-value is less than our alpha. We compare, so we reject, notice the word here, we reject the null hypothesis. This means that men weigh significantly, and we could add statistically significantly more than women on average. Now, what does this really mean? Since men and women weigh different statistically and significantly before starting the program, maybe we need to consider developing a different nutrition or weight loss program for the two groups. Or another way that we can kind of look at it is maybe we need to look at weight loss as a percentage of beginning weight rather than the total weight. which would be more important. So this is an independent t-test. In the next section, we'll use the same data, but we'll be doing a paired t-test.